Good morning. The Subcommittee on Space will come to order. Without objection, the chair is authorized to declare recesses in the subcommittee at any time. Welcome to today's hearing entitled An Update on NASA Commercial Crew Systems Development. I'd like to recognize myself for 5 minutes for an opening statement. The next few years will be busy for space exploration. NASA will be busy not only launching new systems, but they'll be developing new business models, new contracting mechanisms, and new ways of approaching every facet of the challenge of expanding human presence beyond low Earth orbit. Engaging with commercial partners to meet exploration needs is part of that broader effort. I'm very eager to see how we can partner with the private sector to advance NASA's goals. NASA's Commercial Crew Program is part of that effort. And as we assess the merits of this new approach, we must also recognize the hazards of such partnerships. Without diligent oversight by NASA and Congress, these programs could simply end up being corporate welfare and bad deals for the taxpayer. This Commercial Crew Program builds on the Commercial Cargo Program and offers new insights about how government and industry can work together on key tasks. Perhaps even more importantly, this program is a key part of the bigger, broader effort to industrialize low Earth orbit and transition the International Space Station to a new operating model in the next decade. But instead of looking forward and tackling the economic self-sufficiency and operation of the ISS, we are here today looking at not one, but two companies that are behind schedule, may not meet safety and reliability requirements, and could even slip into cost overruns. Rather than being able to praise the success of a new approach to business, we are now confronted with the news that the certification won't happen until at least 2019. This situation gets even worse when we look at the safety and reliability concerns surrounding these two new systems. Both programs suffer from shared and individual issues concerning reliability and safety. The risk that these companies cannot meet their deadlines or safety requirements increases the risk that ISS cannot be successfully or gracefully transitioned in the middle of the next decade. Increasing risks to ISS transition, in turn, increase risks to human exploration programs in general. Further, they decrease the collective appetite for the kind of innovative partnerships that will be vital to a host of future NASA exploration and science missions. Both this hearing and last November's hearing on SLS and Orion get to matters of risk. What is the risk that NASA will be unable to meet its long-term goals of expanding permanent human presence beyond low Earth orbit? Each program features cost, schedule, and performance risks. Those programmatic risks translate into risks to the overall exploration architecture. Both companies are making progress, but certainly not at the rate that was expected, and not without significant challenges to safety and reliability. In order to remedy these problems, NASA may seek additional funding or accept significant risks. Neither of those options is viable. As I said at our recent hearing on SLS and Orion, NASA and the contractors have to execute. I would like to thank our witnesses for their testimony and look forward to getting a better understanding of where we are and what our prospects look like going forward. And now I would like to recognize the ranking member, the gentleman from California, for an opening statement.
Thank you, Mr. Chairman, and thank you for having this timely hearing, and thank you to the witnesses. You know, I represent a district in California, so I have these 5 to 6 hour flights across the country, and a couple weeks ago, you know, I'll download a movie occasionally to watch on that flight, and I downloaded Apollo 13 to watch on the flight. Obviously, I think everyone in this room has seen that movie, but it's a great movie if you haven't seen it. But what it does suggest is, you know, the importance of safety in, you know, commercial crew launches. And, you know, that was almost 50 years ago, and just, you know, watching the importance of safety, you know, watching how, you know, those of us, you know, at NASA at the time, back home improvising, trying to figure things out, using slide rules to, yeah, that might have been an over-dramatization, but they were using slide rules in there. Fast forward to where we are today, and think about the computing capabilities that we have and everything else, but it still doesn't mitigate the danger when you're sending human beings hundreds of thousands of miles away from the Earth, particularly as we start to think about going further and further, and the importance of safety. And regardless of everything that we do to mitigate things, the unexpected potentially can always happen. And as we think about renewing our commercial crew capabilities here domestically, partnering with the commercial sector, safety is paramount. And obviously the balance of meeting deadlines and goals and balancing that with safety. I think the other important part as we start to get it back into commercial crew capabilities here domestically in the United States, I do think we're taking the right approach, partnering with the commercial sector, with NASA certainly in the lead, looking at certification and everything else, but also having redundancy, having two companies that potentially give us that capability, because again, you never know when something unexpected potentially happens. I think for national pride, also allowing the United States domestically not to have to rely on another nation certainly is something that we think about. And then, we don't know what the 21st century in space is going to look like. Certainly you see more commercial interest thinking about building habitats up there. You see folks talk about space tourism, et cetera. So again, as the commercial sector partners with our agencies, I think this is incredibly important. With regards to today's hearing, I'm very interested in looking at and gaining information on safety first. Within that context, the safety driving the timeline as opposed to timeline driving safety. And then really just curious about what those next steps are. If we are unable to hit some of the goals, my understanding is in the fall of this year, we will, the hope is to do some unmanned tests. Toward the end of 2018, to try to do some manned tests, and then to start the certification process in 2019. So I'd be curious, again, to hear from our witnesses and get some sense of how we're going to balance these competing interests, but again, leading with safety, and then hitting our timeline goals. So, Mr. Chairman, thank you for another great hearing, and I look forward to hearing from our witnesses.
Absolutely. Thank you, Mr. Barrow. I really feel old this morning because I used to use a slide rule when I was in college. And I saw that movie again for about the third time about a couple of weeks ago. Okay, I'd like to now recognize the chairman of our full committee, Mr. Smith from Texas.
Thank you, Mr. Chairman. The goal of the Commercial Crew Program was to develop a faster, more cost-effective way to procure space transportation services without sacrificing safety or reliability. The intent was to leverage the lessons learned and the investments made in the Commercial Cargo Program. At the outset, there was hope that contractor funding would decrease the development cost to NASA and the taxpayer, and that this would justify the contractors keeping the intellectual property derived from federal funding. There was also an assumption that the contractors would find other customers, improving economies of scale, which would then lead to lower launch prices for NASA. Finally, there was a presumption that contractors could deliver systems faster if there was less government oversight. Today's hearing is a great opportunity to evaluate whether the program is living up to those goals. Have the contractors funded development cost? If so, how much? If not, why not? And should the government retain the intellectual property? Previous hearings held by this committee indicated that NASA is funding 90% or more of the cost. Has this changed? Are the contractors finding other customers to offset NASA operational cost? The Commercial Cargo Program created two separate Delta II class launch vehicles that have certainly found customers outside NASA. However, the cost to NASA under the second Commercial Resupply Services contract went up, not down. Should we expect costs to grow rather than shrink under the Commercial Crew Program as well? Has the Commercial Crew Program maintained its planned schedule? Are there appropriate incentives built into the contracts to maintain the schedule and penalize delays? This hearing offers us the opportunity to reflect on the status of the program and seek answers to these questions. A lot has happened in the last few years. The program is making significant progress. However, as we will hear from the witnesses, there have been challenges. The Government Accountability Office reported last February that neither Boeing nor SpaceX would be able to certify their systems in 2017. The GAO report and the recently released annual report of the Aerospace Safety Advisory Panel both warned that certification is likely to slide even further to 2019. This was confirmed just last week when we were formally notified that SpaceX's first launch would be delayed again. Further reports from the GAO, ASAP, and IG and others point out that neither company may be able to meet safety requirements. The recently released annual report from the Aerospace Safety Advisory Panel states it appears that neither provider will be able to achieve a no worse than 1 in 500 chance of losing a crew and will be challenged to meet the overall mission requirement of 1 in 200 based on capsule design alone. Meanwhile, as schedules slip, we continue to pay Russia $80 million per seat to take our astronauts to the ISS. This not only creates additional budget pressure on the agency, it hinders full utilization of the ISS and ultimately complicates further exploration plans. With the end of the ISS on the horizon, the clock is ticking on maximizing the return on the taxpayers' investment. The longer we wait for the Commercial Crew Program, the less we can accomplish on ISS. Other programs at NASA, including SLS and Orion and the James Webb Space Telescope, also face significant delays, cost overruns, and challenges. The taxpayers in Congress have neither infinite budgets nor infinite patience. Foreseeable delays, predictable overruns, and performance lapses all have real consequences. Contractors should not assume that the taxpayers in Congress will continue to tolerate this. NASA and its contractors must restore American confidence in their ability to deliver safe, cost-effective leadership in space. This committee has strongly supported the Commercial Crew Program and consistently advocated for full funding. That support continues, but the contractors need to deliver safe, reliable systems on budget and on schedule. Thank you, Mr. Chairman. Yield back.
Yes, sir. Thank you. Thank you very much. And I'd like to now recognize the ranking member of the full committee, gentlewoman from Texas, Ms. Johnson.
Thank you very much, Mr. Chairman, and good morning and welcome to our witnesses. Since the last space shuttle flight in 2011, the U.S. has lacked a domestic human space flight capability and has relied on Russian crew transportation services to transport NASA crew to and from the International Space Station. That arrangement has proved to be very durable in spite of geopolitical tensions back here on Earth. However, it is no substitute for U.S. crew transfer capabilities. This morning's hearing will provide us, hopefully, with an update on the status of NASA's and the industry's efforts to reestablish a domestic capability for launching our astronauts to the space station. NASA's two commercial crew program providers, Boeing and SpaceX, are working toward the goal of conducting test flights, first without crew on board and later, of course, with crew. If these flight tests are successful, the current schedule would have NASA certify the two systems for operational missions sometime in 2019. As we have discussed on numerous occasions in this subcommittee, getting to this stage of the Commercial Crew Program has really not been easy. Our witnesses from the Aerospace Safety Advisory Panel, and the Government Accountability Office will no doubt attest to that point, and the coming end of the availability of the Soyuz seats adds the risk of unhealthy schedule pressure to the other challenges facing the program. Yet, despite the prospect of our access to seats on the Soyuz coming to an end next year, NASA and the two companies cannot afford to cut corners in attempting to prevent a potential gap in U.S. access to the International Space Station. Because, Mr. Chairman, if this is not to be sustainable, the end result of the Commercial Crew Program must be safe and a safe commercial crew transportation system for all astronauts. Next week, NASA will commemorate the astronauts who died in the Columbia, Challenger, and Apollo 1 accidents, as well as other NASA pilots and employees who lost their lives in the pursuit of space exploration. We cannot forget their sacrifices, even as we blaze new trails in space. As the NASA Transition Authorization Act of 2017, consistent with the findings and recommendations of the Columbia Accident Investigation Board, the administration shall ensure that safety and the minimization of the probability of loss of crew are critical priorities of the Commercial Crew Program. I hope that we will have a robust discussion at today's hearing on how NASA and its providers will ensure that planned commercial crew transportation systems are safe enough for our astronauts to fly in, what the challenges are to achieve that level of safety, and what safeguards the ASAP and GAO would recommend. I thank you, Mr. Chairman, for holding the hearing. I look forward to hearing our witnesses, and I yield back.
Yes, ma'am. Thank you very much. Now I'd like to introduce our witnesses who we are going to hear from today. The first witness today is Mr. Bill Gerstenmaier, Associate Administrator of Human Exploration and Operations Directorate at NASA. Mr. Gerstenmaier began his NASA career in 1977 performing aeronautical research and has managed NASA's human spaceflight portfolio since 2011. He received a Bachelor's of Science in Aeronautical Engineering from Purdue University and a Master's of Science in Mechanical Engineering from the University of Toledo. Welcome. Our second witness today is Mr. John Mulholland, Vice President and Program Manager for Commercial Programs at Boeing. Prior to this, Mr. Mulholland served as the Vice President and Program Manager for the Boeing Space Shuttle Program. He was also the Program Director and Chief Engineer for the Boeing Space Shuttle Orbiter Team. Mr. Mulholland received both a Bachelor of Science in Chemical Engineering and a Master's degree in Mechanical Engineering from New Mexico State University. Welcome. Our third witness today is Dr. Hans Koenigsmann, a Vice President of Build and Flight Reliability at SpaceX. He has more than 25 years of experience designing, developing, and building complex avionics and guidance, navigation, and control systems for launch vehicles and satellites. Dr. Koenigsmann received a Master's of Science in Aerospace Engineering from the Technical University of Berlin and a PhD in Aerospace Engineering and Production from the University of Bremen. Welcome. Our fourth witness today is Mrs. Cristina Chaplain, Director of Acquisition and Sourcing Management at the U.S. Government Accountability Office. Among other topics, Mrs. Chaplain has led reviews on the ISS, Space Launch System, and Orion crew capsule, as well as commercial cargo and crew projects at NASA. Mrs. Chaplain received a bachelor's degree in international relations from Boston University and a master's degree in journalism from Columbia University. Welcome to you. Our final witness today is Dr. Patricia Sanders, Chair of the NASA Aerospace Safety Advisory Panel, ASAP, and she previously served as Executive Director of the Missile Defense Agency, as well as Director of Test Systems Engineering and Evaluation at the Office of the Secretary of Defense. She received her PhD in mathematics from Wayne State University in Detroit, Michigan. And welcome to you, Dr. Sanders. I would now like to recognize Mr. Gerstenmaier for 5 minutes to present his testimony. Mr. Gerstenmaier.
Thank you. Chairman Babin, Ranking Member Barra, and members of the committee, thank you for the opportunity to be here today to represent the NASA team supporting the Commercial Crew Development Program. Over the past several years, there's been a tremendous amount of work completed. The hard work completed, the analysis, the design work completed, as well as the testing is direct evidence of the tremendous amount of work that has been accomplished. I'm sure the other panelists will cover in detail the quality and quantity of the work completed. My written testimony additionally includes references to the work that's been completed. The work completed took longer than originally planned, but many technical issues were discovered and resolved. This extra time that was taken in this development phase will help reduce the risk and magnitude of additional schedule delays. This is a critical time in the program as manufacturing is in high gear, testing is being completed, and verification and validation requirements are being addressed by NASA. The program is approximately 1 year away from the first crew flights to ISS. This is an excellent time to reflect on the work completed and the work to go. This hearing is very timely. The NASA team is fully aware of the amount of work to go and the requirements that need to be completed, reviewed, and closed by NASA and its partners. NASA's been fully engaged with the partners during their design and testing and manufacturing processes. NASA has directly witnessed tests, NASA has done our own assessments in selected areas, and we have requested extra tests from our partners and even done our own tests. This involvement and interaction helps as NASA reviews paper for closure. NASA is aware of the schedule, but not driven by the schedule. NASA worked last year to add additional Soyuz flights to protect if additional time was required for certification. Soyuz capability is available through the fall of 2019. The manufacturing time of a Soyuz of approximately 3 years will not allow additional Soyuz to be manufactured. We are brainstorming ideas to provide additional schedule time if needed. Additionally, as we do this, we are looking for ways to allow the partners to reach an operational tempo after certification. The ISS program is looking at ways to maximize ISS operations while allowing for some delays in launch dates. Having selected 2 partners helps to relieve the schedule concerns if a major problem arises. NASA is doing everything possible to be prepared and allow time for a solid review of the design and the data. NASA is aware of the schedule can be a negative influence to a good design and safe flight if it is the only consideration. As one way to protect against undue schedule pressure, NASA has implemented independent technical authorities. This allows for rigorous discussion on technical topics. This discussion could be seen as a negative, but should rather be seen as a positive and a way to technically compare and contrast design options. NASA is prepared to make timely decisions. Many of these decisions will be risk versus risk decisions, and NASA is prepared to make these based on the technical data available at the time of the decision. Even after certification is complete, we must continually compare the actual performance of the systems to the designed performance. We also must look at the environments in which the vehicles is flying to again make sure that the vehicles have the proper safety margins. We need to be prepared and allow the design to change even after the official formal certification. This is a critical time in the commercial crew program. The decisions being made today will affect the safe and successful operation of the systems for years to come. NASA is fully ready for this phase and has the insight and ability to certify a safe and reliable system in a timely manner. I look forward to your questions and a good, informative hearing. Thank you.
Thank you, Mr. Gerstenmaier. Now I'd like to recognize Mr. Mulholland for 5 minutes to present his testimony.
Chairman Smith, Chairman Babin, Ranking Member Johnson, Ranking Member Barra, and members of the committee. On behalf of the Boeing Company, thank you for the opportunity to provide an update on the Commercial Crew Program. We are proud to have been a trusted partner with NASA on every domestic human spaceflight program. We have a unique and singular understanding of the strategic importance of having an American-made crew transportation system for safe, reliable, and affordable access to low Earth orbit. I will emphasize safe again, as for that is our ultimate judgment on our mission. That said, we understand that having this capability as soon as possible is critically important for the International Space Station to continue its important mission as a world-class national lab. We have the full support of the Boeing Company and a strong value-added relationship with our NASA partner. We've made tremendous progress and have overcome several issues that are typical of complex development programs since we last testified in 2015. Our launch vehicle, the Atlas V, has flown 74 missions with 100% mission success, providing unparalleled safety, mission assurance, and schedule reliability. The launch site crew access tower has been erected, and other site modifications are progressing well ahead of need. The structural test article entered test in December 2016 and is undergoing a complex series of static loads, modal analysis, ordnance operation, and separation system verification. The test series is greater than 50% complete. The service module hot fire test article has been delivered to the test site and is near completion of cold flow testing. Following this phase, the system will be loaded with propellant and all propulsion system functions will be tested. Spacecraft 1 has finished initial power-on testing, ground verification testing, and is undergoing final outfitting prior to mate of the crew module and the service module. This test article will be sent to the test site for the pad abort test in Q2 2018. Spacecraft 2 initial power-on testing will occur in early February, followed by final outfitting and mate prior to being shipped to the test site for environmental qualification testing early this summer, before returning to Florida for retrofitting to support the crewed test flight in Q4 2018. Spacecraft 3 lower dome secondary structure is in build to support initial power-on testing in April. This spacecraft will be used for the uncrewed test flight in Q3 2018. The land landing qualification testing is successfully completed, proving our system can safely land on land under both nominal and failure cases. Flight software released its latest drop in December and currently stands at over 98% of full functionality. Over 25% of the verifications to be approved by NASA have been completed and delivered, and over 11,000 hazard control verifications have been closed out and delivered. Training is underway with NASA's commercial crew cadre and our missions operations team, thanks to new state-of-the-art Starliner training systems at the Johnson Space Center. As you can see, the team has successfully transitioned from design into integrated build and test. The last time I was here, there were some concerns over whether or not NASA and its partners were providing the Aerospace Advisory Panel with enough insight into our systems and processes. I promised this committee and then Chair Admiral Dyer that Boeing would continue to provide the ASAP the appropriate level of access into the development of the Starliner. In fact, we offer all of NASA's advisory committees and reporting agencies, including the Government Accountability Office, full insight into our progress, challenges, and schedule. We believe transparency is essential in this business, and I personally feel that the reviews, findings, and feedback add value to our systems and processes. We are well aligned with our customer on crew safety and mission assurance, and our analyses show that we exceed our requirements for crew safety. While we're focused on meeting our 2018 forecast dates, we're equally committed to performing those safely. We bring the same quality to commercial spaceflight that we bring to our servicemen and women, astronauts on board the station, and to the traveling public every day. Thank you again for the opportunity to be here today, and I look forward to answering your questions.
Thank you, Mr. Mulholland. I'd like to now recognize Dr. Koenigsmann for 5 minutes to present his testimony.
Thank you. Mr. Chairman, Ranking Member Bera, Ranking Member Johnson, and members of the committee, thank you for the opportunity to participate in today's important hearing. SpaceX is proud to partner with NASA to develop the next generation of safe, reliable, and affordable space transportation for America's astronaut. On behalf of my more than 6,000 colleagues at SpaceX, I'm pleased to be here to provide an update on our progress towards the first flight with crew later this year. Mr. Chairman, SpaceX is designing, building, testing, and will soon operate the safest crew transportation system in history. We are working in close partnership with NASA, and we are deeply grateful for the ongoing guidance and confidence. The commercial crew program stands as a true example of the innovative safety improvements and cost savings that can be achieved under an effective public-private partnership. In addition to designing and building the hardware, we will conduct all mission operations from crew training, launch, and on-orbit activities to post-flight recovery. NASA sets high-level requirements and certifies us to fly. The SpaceX transportation system leverages our proven Falcon 9 launch vehicle and our Crew Dragon spacecraft. Falcon 9 has successfully launched 46 times since 2010, including 18 flights in 2017, a new record. The vehicle has been designed from day one with robust margins, engine-out capability, and advanced safety systems to support astronaut flights. Falcon 9 is also the only operational orbital launch system with reusability capabilities, which improves reliability and lowers cost. The Crew Dragon spacecraft builds upon our successful flight heritage with our current cargo-configured Dragon spacecraft. We developed Dragon under the COTS Space Act agreement with NASA. Since 2010, Dragon has successfully flown to orbit and back 14 times, routinely sending cargo to the space station and back to Earth, a capability unique to Dragon. Crew Dragon takes this proven design and incorporates upgrades to ensure a safe and comfortable ride for astronauts. The biggest safety innovation on Crew Dragon is our launch escape system. Fully integrated into the spacecraft, the system will safely propel Crew Dragon and the astronauts inside away from the launch vehicle in the event of an emergency. Unlike past generation systems that could only be used for the first few minutes of flight, our Super Draco system gives the escape capability all the way to orbit. This is a major advancement for astronaut safety. I'd like to give you an overview of some of the major achievements we've made during the program to date. In May of 2015, we conducted a successful paired abort test. Here, we simulated an emergency on the launch pad. Within a fraction of a second, the spacecraft's escape system propelled it away from the pad, validating crew escape capability in the event of a paired emergency. In November of 2016, we completed functional testing of our life support system. We also completed a key spacesuit qualification milestone, which included the lead suit engineer wearing the spacesuit he designed in a vacuum chamber to prove his capability. In September 2017, we successfully mated Dragon's pressure and service section of our first flight vehicle. This was a major milestone and a big step towards flight later this year. And in December, we completed the first round of qualification testing for our parachute system. We have completed nearly all technical development required for Crew Dragon. At this point, we have multiple Crew Dragon spacecraft in testing or built right now. Over the course of this year, we will complete final integration and validation ahead of our first astronaut flights. In August, we plan to conduct an uncrewed test flight of the full system to and from the space station to validate that the system is safe for crew. Then we will launch our test flight with 2 NASA astronauts for a week mission to and from the space station in December. Following that, we will begin operational flights with a 4-astronaut NASA crew complement. Safely and reliably flying commercial crew missions remains the highest priority for SpaceX, and we will launch NASA astronauts only when both we and NASA are ready. Mr. Chairman, I appreciate the opportunity to testify before you today, and I look forward to answering your questions.
Thank you very much, Dr. Koenigsmann. I'd like to now recognize Ms. Chaplain for 5 minutes to present her testimony.
Chairman Babin, Ranking Member Bera, Chairman Smith, Ranking Member Johnson, thank you for inviting me today to discuss NASA's Commercial Crew Program. GAO has been assessing the progress of commercial crew for several years. In the past, we've also reviewed the Commercial Cargo Program known as COTS, as well as NASA's human spaceflight programs. As you know, NASA's acquisition strategy on the Commercial Crew Program is similar to the one it used on COTS, but different than every other spacecraft it is built for humans. For commercial crew, each contractor develops, owns, and operates its spaceflight systems. The contractors have access to NASA expertise and resources throughout the development process, but NASA engineers are not making design decisions, and NASA personnel are less involved in processing, testing, launching, and operating the crew transportation system. In the end, NASA will buy a crew transportation service, much like it does for the station's cargo. While Boeing and SpaceX are making significant progress, both continue to experience schedule delays. It has been 3 weeks since the program's original December 2017 goal to secure domestic access to the space station, yet neither contractor has yet to conduct a test flight. In fact, final certification dates have slipped to the first quarter of calendar year 2019, and we found that the program's own analysis indicates that certification is likely to slip into December 2019 for SpaceX and February 2020 for Boeing. Several factors could contribute to additional delays to the schedules presented here today. One, the contractor schedules have been aggressive from the onset of the program. To date, Boeing has reported a delay 6 times, and SpaceX has reported a delay 9 times for at least one key event. According to NASA, both contractors assume an efficiency factor in getting to the crewed flight test that the program office does not assume in its schedule. The contractors also use their schedule dates to motivate their teams, while NASA adds additional schedule margin for testing. Aggressive schedules and delays are not atypical for programs developing new launch vehicles and/or crew vehicles, and we see them on all types of contracts. But in this case, the delays and uncertain final certification dates raise questions about whether the U.S. will have uninterrupted access to the space station beyond 2019. NASA may have to purchase additional Soyuz seats, but as Mr. Gerstenmaier mentioned, there are limits to how it can do so. Further, these delays may lessen NASA's return on investment with its contractors. There are also programmatic and safety risks that may result in more delays. Again, not unusual for programs of this nature, even at this stage of development. Boeing, for example, is addressing a risk that the Starliner's heat shield could damage the parachute system during reentry into the Earth's atmosphere. SpaceX needs to address concerns about its plans to fuel the launch vehicle after astronauts are on board. In addition, both contractor systems must meet a standard for crew safety that is much higher than that for the shuttle. A considerable amount of work remains to be done to determine whether the contractors will meet this requirement. Lastly, NASA's program office could also face delays and workload problems that can cause delays. Program officials told GAO that one of their greatest upcoming challenges will be to complete 2 oversight activities concurrently. These include conducting phase safety reviews and verifying that contractors meet requirements. The program's ability to smooth its workload is limited as the contractors control their own schedules. Last year, though, we found that the proposed schedule changes could alleviate some overlap in terms of the program office's workload. We will be further assessing the Commercial Cruise Program schedule and risks, as well as issues surrounding safety, and look forward to reporting on the results of our work later this year. Chairman Babin and Ranking Member Bera, this concludes my statement, and I'm happy to answer any questions you have.
Thank you, Ms. Chaplain. We appreciate it. I'd like to now recognize Dr. Sanders for 5 minutes to present her testimony.
Chairman Babin, Ranking Member Bera, Mr. Smith, and members of the subcommittee, thank you for the opportunity to appear before you today to discuss the status of NASA's Commercial Crew Program. The Aerospace Safety Advisory Panel believes that NASA's Commercial Crew Program is at a critical juncture, well beyond paper design, with hardware being produced, testing underway, and first flights, uncrewed demo flights followed by crewed demo flights on the horizon. This is a time when it is important to retain focus on program details while not giving in to schedule pressure, to maintain schedule awareness, but to continue with program plans without neglecting, shortchanging, or deleting planned content. We continue to strongly caution that any wavering in commitment negatively impacts cost, schedule, performance, workforce morale, process discipline, and most importantly, safety. We see continual, steady progress towards providing the capability for crew transportation to low Earth orbit and the International Space Station, with both providers currently planning for flight tests later this year. We also know that based on the quantity, significance, and associated uncertainty of work remaining for both commercial providers, the panel believes that there is a very real possibility of future schedule slips. There are several major qualification and flight test events that historically are scheduled drivers or could reveal the need for additional work. These are things such as pyroshock qualification tests, parachute tests, engine hot fires and qualification runs, abort tests, and both the crewed and uncrewed demos. In addition to the technically complex test and qualification work remaining for the providers, NASA also has, as Kristen has pointed out, a significant volume of work remaining itself. The final phase of the NASA safety review process, where verification evidence of hazard controls is submitted by the provider and disposition by NASA, remains ahead, as well as the majority of certification requirements verifications. It's not unusual for that to come at this point in time in the program, but that is remaining to be done. Despite the volume of remaining work, the technical challenges, and the upcoming end of the Soyuz transportation for U.S. crews, the panel sees no evidence that the program leadership is taking or making decisions that prioritize schedule over safety risk, over crew safety. We expect to see several significant certification issues brought to culmination in the next year that will require NASA careful consideration on risk acceptance decisions at a very high level within the agency. It is possible that in some cases, the most beneficial and balanced options for the mission will require a decision to accept a higher risk. We note that the strategy of funding two providers was adopted in part to avoid a situation where NASA would be forced to accept undesired risk to maintain crews on the International Space Station. This requires one provider to be certified and ready to fly crew to the station by mid to late 2019. Certification of the second provider could happen after that time. The panel believes that NASA is addressing safety properly, but space can be a decidedly hostile environment, and human spaceflight is inherently risky. There's no excuse for negligence in the safety arena, but it's impossible to eliminate or control every potential hazard. With the Commercial Crew Program, NASA has introduced an approach to developing spaceflight assets in cooperation with commercial providers. The future brings potential for more partnerships, bringing more opportunities and challenges with respect to safety processes and mechanisms. In the coming year, the panel plans to spend focused effort on commercial crew and also look to the future of responsible and exciting human space exploration. And I look forward to your questions.
Thank you very much, Dr. Sanders. I'd like to introduce a young lady that's from my district. She's from Texas A&M as an intern from Dayton, Texas, District 36, Ashton Stevenson. Raise your hand or stand up, Ashton. Thank you. Good to have you here this morning. I want to thank the witnesses for their testimony, and now I'd like to recognize myself for 5 minutes for questions. Recent press reports indicated that a U.S. government mission named Zuma may have either failed in orbit or the launch could have been unsuccessful. I do not want to discuss anything classified in an open session. The circumstances surrounding this mission do have a direct impact on NASA and this committee's jurisdiction and oversight responsibilities. For instance, the launch vehicle used for the mission was developed with substantial NASA funding. The rocket is also scheduled to launch the Transiting Exoplanet Survey Satellite mission in March. More importantly, the rocket will be used in the Commercial Crew Program that we are discussing today. Knowing the operational history of the system that NASA will put people on is an issue of life and death, literally. Similarly, the Zuma spacecraft was reportedly built by Northrop Grumman, who is building a $9 million James Webb Space Telescope for NASA. Understanding Northrop Grumman's work is clearly important to NASA and the committee. So I'd like to address the first question to you, Dr. Koenigsmann. Thank you for committing to provide an unclassified briefing on the Zuma mission. If the committee needs more information, will SpaceX provide this committee with a briefing on this mission in a classified setting?
Well, thank you for your question. I want to point out on the Zuma mission that we relayed the information that Falcon 9 performed as specified, and it actually performed very well as specified, and that we are picking up the launches by the end of the month as we planned all the time. Regarding a briefing, we will go through the proper channels and follow the protocol. As you pointed out, we can't talk any details in this particular setting.
Okay, thank you. And to Mr. Gerstenmaier, does anyone at NASA know the details of the Zuma mission?
We do not know the details of the mission per se, but we've been informed by others that if there's any mishap investigation or any other activities that are involved, we will be appropriately involved in that activity.
Okay. Well, why would NASA place astronauts on systems without knowing the system's full operational heritage? And it brings to mind President Reagan's use of the Russian proverb, trust but verify.
Again, we will know if this is declared a mishap and we understand that it's a mishap, NASA will be informed and we will have appropriate personnel participate in those mishap activities.
Okay, thank you. Following the explosion of the SpaceX rocket and the Amos 6 spacecraft on the launch pad, SpaceX was not able to determine a single most probable cause of the event. Instead, identifying several credible causes related to the composite overwrap pressure vessel, or COPV, helium tank. SpaceX modified its operations to prevent similar events going forward, but still doesn't know the exact cause. The ASAP report states the panel considers this to be the most critical step in clearing the COPV for human spaceflight, as it allows NASA and SpaceX to identify the credible failure mechanisms, hazard scenarios, and controls, as well as understand the safety margins on the system. The report goes on to state, in our opinion, adequate understanding of the COPV behavior and cryogenic oxygen is an absolute essential precursor to potential certification for human spaceflight. Dr. Sanders, how many launches with a stable configuration should NASA require SpaceX and Boeing to achieve before certification?
That's a very difficult question. Thank you. Right now, I believe NASA is planning to require 7 launches with that configuration, and we believe that's an appropriate number. There's some statistical evidence that Mr. Gerstenmaier could probably talk to a little bit better than I can on why that is a reasonable number. It is not a totally random number. It is a number that's predicated on having more than a few and having a time frame in which you can actually accomplish those and still get on with certification and make the right risk decision on flying.
Okay, thank you very much. And Mr. Gerstenmaier, will NASA certify SpaceX to carry NASA astronauts without knowing the root cause of the Amos 9 failure? And will NASA allow SpaceX to use the load and go procedure for either commercial crew or the uncrewed missions?
Again, we may not ever know the exact root cause of the failure that was associated with Amos, but we have a very intensive test program in cooperation with SpaceX and NASA doing some testing to identify the contributing causes or potential causes of that failure. SpaceX is doing a redesign of the composite overwrap pressure vessel system, and Hans can talk to you about the details of that. We're participating in that. We will do the testing. We will understand the most likely contributors, and we will remove those from the failure chain and make sure that we're really ready and safe to go fly and the system is ready for crew before we put them on board. In terms of the so-called load and go, we're in the process of looking at the best time to put the crew on the vehicle. We'll take into account the hazards associated with the specific vehicle designs, how much propellant is being actively loaded, what systems are operating, what hazards are associated with those activities, and we will find the appropriate time, along with the contractors, to put crew on this particular vehicle design that is most appropriate for the lowest risk to our crews and overall lowest risk to or gives us the highest probability of mission success. And we're in the process of working with both providers to determine the appropriate time to put crew on the vehicles.
Excellent. Thank you very much. My time has expired, so I'd like to go to the gentleman from California, Mr. Barra.
Thank you, Mr. Chairman. Mr. Gerstenmaier, in your opening testimony, you talked about how NASA is aware of the schedule but not driven by the schedule. I think that those were the terms that you used. And Ms. Chaplain, I believe I heard you correctly that while NASA's engineers are involved working with both Boeing and SpaceX, it's mostly internal at Boeing and SpaceX, that NASA's engineers aren't intimately involved in the design and manufacturing. Did I hear that correctly?
Yes, not as involved as they would be in a typical program, such as like an Orion spacecraft.
Okay. And again, this is an evolution of, if I think about the early days of Apollo, where NASA was the launch vehicle, NASA was the commercial crew vehicle, was the lunar landing vehicle, was the science vehicle. I mean, it's not a bad thing to see evolution and progress. 50 years ago, we would not have imagined U.S. astronauts going up to a space station on a Russian vehicle, but yet that's where we find ourselves today. I just think I guess, Mr. Gerstenmaier, how intimately are NASA engineers involved as we start to go back into space? So
we again look back at kind of our history and experience in spacecraft design, development, and safe operations. And there's certain areas that we deemed as higher risk across the systems. We also look at the specific designs where problems have occurred, we've seen in other testing, and then we involve ourselves very heavily in those areas. So, for example, we talked about the composite overwrap pressure vessel activity. We have our own test facility at White Sands, of which we're working with SpaceX to go do a kind of independent test to verify and validate that that's there. So we take these selected areas. We don't do it across the board with every design element, but the ones that we think are have the highest risk or have the highest potential to be a safety impact, we're heavily involved in those areas, and we're working hand in hand with both contractors. Another area is parachutes. We're very heavily involved in the parachute design activities, certification activity. We're using our experience we've had with the Orion spacecraft. We're providing that to both Boeing and SpaceX. They can use that in their designs, and we have our engineers participating with them in those activities. So we selectively pick the areas that we think are highest risk, and we delve into the area that we need. If we see something we don't like, we can ask the contractors to do extra work for us, or we can do testing ourselves.
Okay, and that level of cooperation, it's coming from NASA, but I guess to both of the contractors, Mr. Mulholland and Dr. Koenigsmann, you're also reaching out to NASA knowing that they have critical expertise and obviously a lot of knowledge from years of sending people, crews.
Yeah, absolutely. I think NASA has added a lot of value to the process. From the very beginning, we thought it would be advantageous for us to embed NASA within our team. So we've got NASA personnel in our factory every day with us. We have weekly review meetings across all the technical teams. They're in our engineering review board. They provided a lot of value, and we are dedicated to doing this transparently.
And the same with SpaceX.
And yes, it's a very similar situation for us too. We have NASA personnel on site at every workday. We include them in important meetings and in some of in the risk boards and some other boards. We have a very close relationship with NASA, and we actually share hardware and test plans regarding some of the tests we're performing here. So it's in my opinion, it's more a hand-in-hand cooperation, and it's not a we do the work and this is a much closer relationship than I envisioned.
In our conversation yesterday, right now the contract between NASA and the contractors are for single-use vehicles. So, for the Dragon vehicle, it would be a new one each time you took a crew up, and is it the same for Starliner as well? That these would be single-use in the current contract. So.
From a Starliner perspective, we have a two-piece spacecraft. We have an expendable service module that provides the propulsion for orbit, on-orbit adjustments, the deorbit burn, and also aboard if we had to. There's a new one every flight. The benefit that our system has is we land on land, combination of parachutes and airbags, that allows reusability. So we will reuse the crew module up to 10 flights.
Mr. Gerstenmaier, currently though, is NASA contracting for the reuse of that crew vehicle, or is it a new crew vehicle each time?
As Mr. Mulholland just explained, in the case of Boeing, the vehicle is reused.
Is reused.
10 times. In the case of SpaceX, we've asked for a new vehicle each time, and we'll continue to review that with SpaceX.
Okay. And in the long-term planning with the reuse of vehicles, is the expectation that will bring costs down over time? So.
Yes, that's what we believe, that it has a potential to bring down costs. We're also looking even at the Orion spacecraft for potential reuse and VIT in certain areas. There's some advantage of using a reused vehicle in the fact that you've got a chance to actually see it in flight. You get to see its performance, as long as it's not taking life out of the system or it's not degrading the system. The fact that it's flown gives you some insight in the environment that it's going to operate and gives you some insight into operations that may actually be beneficial to you.
Is there an expectation potentially, if Dragon's being designed to be reused as well, to think about Dragon as a reuse vehicle as well, or over time, or Dr.?
Maybe Hans might address that better than myself.
Yeah, Dragon is designed for reusability, and we actually have been able to demonstrate that on the current cargo Dragon. Particularly with the last launch, we used a first stage and a cargo Dragon, so that was a major accomplishment, in my opinion, in terms of reusability. And I do want to emphasize, too, that getting the vehicles back is an enormous opportunity to learn about the flight loads and what happened during flight, not just by inspecting it, but you can also add additional sensors that you then can download data from and don't have to rely just on the RF links. So in our opinion, it's both a long-term cost savings and an incredible reliability advantage.
Okay, great. I've gone over my time, Mr. Chairman.
Yeah, thank you very much. I'd like to now recognize the gentleman from Alabama, Vice Chairman of our subcommittee, Mr. Brooks.
Thank you, Mr. Chairman. I'm going to read from an article that was published earlier this week entitled "Doubts About SpaceX Reliability Persist as Astronaut Missions Approach." It was in Forbes magazine. The author is Lauren Thompson, January 15th, 2018. And then I'm going to ask some questions in fairness that we can have a response. Quote, in 2015, a Falcon 9 cargo mission to the International Space Station exploded minutes after launch, costing NASA $110 million. In 2016, an Israeli commercial satellite was destroyed on the ground when supposedly routine fueling procedures went dramatically awry. The launch pad was damaged by that explosion. In 2017, the latest version of the company's Merlin rocket engine blew up at a testing facility in Texas. And now SpaceX has begun 2018 with yet another catastrophe, referring to the billion-dollar spy satellite that was recently lost. Resuming the quote, maybe SpaceX really isn't responsible for the latest failure. The problem might have been caused by a payload adapter that Northrop Grumman, the company that had also built the lost satellite, supplied. But launch providers usually have final responsibility for tip-to-tail readiness before a rocket lifts off, and competitor ULA has successfully employed a variety of payload adapters to attach satellites to its rockets. The most worrisome aspect of this apparent pattern is that the same SpaceX launch vehicle will begin flight tests later this year to carry astronauts to the International Space Station. And I would add from another part of the article, quote, by way of comparison, United Launch Alliance, SpaceX's sole competitor in the military launch business, hasn't lost a single payload in 12 years and 124 missions, end quote. Dr. Koenigsmann, you made a comment in your remarks in chief that SpaceX is achieving or attempting to achieve its goal of, quote, safe, reliable, and affordable, end quote, launches. This record that is mentioned in the Forbes magazine article, do you consider that to be consistent with a, quote, safe and reliable and affordable, end quote, launch record?
Well, the record in this paper needs to be adjusted for accuracy, I think.
Please do. That's why I'm giving the opportunity.
Yes, thank you. Thank you very much for that. For once, the quoted test incident in Texas was not an engine explosion. It was a fire on a test stand when the engine wasn't even running, and there was a test procedural error. It has nothing to do with the engine itself. Regarding Zoomer, we talked about this earlier. I can't, unfortunately, present any details. I can only reiterate that Falcon 9 did everything Falcon 9 was supposed to do. On that record, the other two incidents are a while back, and we did learn our lessons on both of those, which is obviously not desirable, but at the end of the day, it's a thing we learned, and we improved the vehicle based on what we saw during those incidents into a much safer vehicle. We took, in both cases, we had investigations with government partners, NASA, FAA, the Air Force, and so on and so forth. And we very openly discussed and presented our corrective action and acted on them since then, which in my opinion makes us a much better vehicle. I do want to point out at the same time that Falcon 9 has actually characteristics that make it intrinsically safe. For example, it has a 9 engines on the first stage. You can lose an engine and make mission. You can actually lose 2 engines in some cases. Not that we ever, not that I ever hope that will happen, but obviously that is a tremendous guarantee. If you lose engines in other rockets, and I want to point out our engines are also domestically produced, then obviously, this is much more difficult for other vehicles that have less engines. So that makes it safer. I also pointed out reusability was already is a great point to get the vehicles back and inspect them. That is something that we started doing. I think it was not December this last year, but the year before, and ever since then have we had a chance to inspect the vehicles and to make sure that we actually.
Please, I have a follow-up question for Ms. Chaplain, and I gave you as much time as I could.
Sorry.
And I appreciate your correcting the article as you understood it with Lauren Thompson, where you agree with 2, you contest 1, and then the other were still yet to be determined. But Ms. Chaplain, how does the GAO evaluate SpaceX's record or goal of safe and reliable and affordable?
Well, on the issue of safety and the accidents mentioned today, I would just remind people that DoD went through its own phase of having launch accidents right before their current program started, the Evolved Expendable Launch Vehicle. And once that started, they realized pretty quickly on that they had to add mission assurance. So they've had a lot of time in the past to learn from mistakes, to do the things that they need to do to get safety and mission assurance into the program. In my view, I think some of that learning is still going on here for the providers, because they're new vehicles, they're new to the government arena, and procedures, mission assurance, things like that are things they're going to be learning over time, and they've already learned quite a bit.
Thank you for your insight and rebuttal of the article. I appreciate it.
And I'd like to recognize the ranking member, Ms. Johnson from Texas.
Thank you very much. Excuse my voice. For Gerst, the ASAP report discusses the accident investigation regarding the on-pad explosion of Falcon 9 rocket in 2016. And the report says that NASA conducted an independent review in addition to the standard accident review. Has that been distributed yet?
No, it's not, and it's in review now. We have a summary of that review, or that report in review with SpaceX, and as soon as we complete the discussions with them, we'll have that summary available for folks to take a look at.
Okay, we look forward to reviewing that. For Dr. Sanders, it's my understanding that one of the commercial crew launch vehicles, the Falcon 9, has experienced several primary mission failures over the past 4 years and suffered a major engine anomaly in recent months, any of which occurrence would have forced a stand down if it had happened to the space shuttle. In addition to other commercial crew launch vehicle, the Atlas V is powered by the Russian-built RD-180 engine, for which detailed design data is still unavailable. What will NASA need to do to ensure that either of the launch systems will be safe enough to fly astronauts on?
Thank you. NASA has a very rigorous certification program in place for both commercial crew providers. There are a very large number of verification notifications that have to be filed. There's evidence that has to be provided from the tests that say they have met all these requirements. I think that by the time they weed through all of that, NASA will be able to make a reasonable decision relative to residual risk. The problems that have experienced with Falcon 9, as Dr. Koenigsmann has just said, have been addressed in the past, but there's still work to be done, particularly on the commercial overwrap pressure vehicle. The RD-180 data, or lack thereof, for the launch vehicle for the Boeing variant, I think has been resolved by finding an alternative way to get insight into that design.
Thank you very much. Ms. Chaplain, would you like to comment on that?
I think there's going to be some gaps as they come to the end, and they're going to have to make a risk-based decision on whether to go forward with some gaps in knowledge. I don't think you're going to get complete knowledge of the Atlas V. That program began as a commercial program, and there wasn't some data attained that we've never been able to get. So at some point, NASA's just going to have to decide how much is the insight they have enough, is the track record enough, is the data they've gotten alternatively enough, and they'll have to make their own risk-based choice.
Thank you very much. Thank you, Madam.
Is she done? Okay. And now the gentleman from Oklahoma, Mr. Lucas.
Thank you, Mr. Chairman. And clearly, the committee is extremely sensitive about both safety and cost. I'd like to begin my discussion, of course, with the most important question, safety. Mr. Gerstenmaier, since this is the first time NASA will be certifying a commercial crew system for human spaceflight, could you expand for a moment about the differences between what you're doing will be doing in the way of commercial system certification versus the certification process you would be going through for a NASA-developed system?
I think the simplest way to describe it is we have a shared mission assurance or safety responsibility with the partners, where the partners have responsibility to show that the vehicle is safe on their own, to show that it can be used for the intended activities that ferry crew to and from space. But then NASA also ultimately has the certification responsibility when we put our crews on those vehicles. So then we do a detailed assessment along with what they've done. So there's some things we've delegated to them to do to be fully certified, to say they're ready to go. And there's aspects where we double check, we overlook, and we oversee all aspects of what they're doing. So even the areas that they say are certified, we've taken a look at them, we've determined they're appropriate to put our crew on board. Whereas if it's our own internal program, we would do all that work ourselves.
And to that end, let's talk for a moment about the cost issues, and I turn to our friends from Boeing and SpaceX. One of the primary reasons for the private sector partnering in developing these systems, of course, was the concept that providing astronaut access to the International Space Station, the development cost to be shared by the contractors. I think we've had testimony before this committee indicating perhaps somewhere in the 80–90% range of the development funds so far have been provided by NASA. I guess the question I'd simply put to you, how much skin in the game do each of you actually have, your organizations? And whoever would prefer to touch that first.
Well, Congressman, thank you. I don't have specific data available for me today on the amount of investment. The investment from the Boeing company has been significant. And we consider this a strong partnership and an endeavor that we're fully committed to.
I want to say we have all the skin. The future for us is Crew Dragon and Falcon 9. But with respect to this particular number, I have to take this for the record. I don't remember this particular number. I do remember the number for the previous Crew Dragon contract, which was significantly higher percentage-wise.
And clearly the reason I ask this question is the same reason the constituents inquire about this. Simply put, whoever is successful, you accomplish something that will have benefits to your enterprise for a generation or two. So it's a legitimate point back from our folks. Expand for a moment also, if you would, about your dealings individually, company-wise, with NASA so far as you go through this certification process. Have you had any surprises?
Let me just start. Yeah, so I want to point out we have an excellent relationship with NASA. I mean, obviously you have to I guess, get a working relationship on the working level, and that takes a little bit of time until we establish that process. But by now we know how to go through the certification process, and it's not that this is something that happens once we're all done. This is ongoing at this point in time, and works in parallel with the hardware development. I'm pretty confident that we will finish this in time and get the astronauts up there before we have to fly any Russian vehicles. And obviously, the test flights are as planned later this year.
Obviously, a very strong relationship with NASA. We've been a part of every human spaceflight program from the beginning. I think the proof of the relationship is in the product. And as of today, of the 800 verifications, as we look forward to certification of the vehicle, of the 800 plus verifications that we have to complete and send over to NASA, over 200 have already been delivered, and of those, over 150 have already been approved. The other big part of certification is the verification of hazard controls. We have 16,000 hazard control verifications that we have to present to NASA. Of those, over 11,000 have already been dispositioned and given to NASA for review. So to me, the proof is in the product, and the partnership that we have and the disposition of those successfully speaks volumes.
Thank you. I yield back, Mr. Chairman.
Yes, sir. Thank you, Mr. Lucas. The gentleman from Illinois, Mr. Foster.
Thank you, Mr. Chairman. One of the large cost drivers in any of this sort of project is the high-level specification on the probability of loss of crew, and an equally important number, the probability of loss of mission. You know, it's my understanding that it's 1 in 270 is viewed as the an acceptable probability of loss of crew, and you sort of design around that. Is that a correct understanding? Yeah, so
Yes.
all right. And so what is the number then for an acceptable probability of loss of mission, which is presumably allowed to be significantly higher and perhaps more of an economic trade-off? Is there a design number for that as well?
The requirement for loss of mission is 1 in 55.
Okay. All right, so that's, now, which of the Falcon 9 accidents that have been talked about would have resulted, had they been manned, would have resulted in a loss of crew as opposed to loss of mission?
Thank you very much for that question. It's certainly the first incident that we had, or mishap, the crew would have been saved with the launch escape system. There's no question about that, because Dragon.
This is the
This is the
on-pad.
No, this is the one in flight.
The one in flight,
Yeah,
yes.
as we can see, Dragon's heat shield acts as a barrier there, and we can see Dragon separate in this particular case. In fact, we made changes on the Dragon software, because if we would have deployed the parachute, we might have been able to save the capsule at that particular point. So the launch escape system would have helped there, absolutely. The same is true for the paddleboard system, which we tested, in last year, 2 years ago, actually.
This is
Right.
the pad explosion.
No,
incident.
this is addressing an incident on the pad. In this case, it's.
Now, how long did you have? I think I read somewhere 93 milliseconds from the first anomaly in the telemetry.
It's very short, and.
And would that have been sufficient for the crew escape?
It competes with starting up the engine, so it's certainly a race condition there. But I personally believe that the heat shield and the structure on Dragon would have protected the astronauts sufficiently to let the engine start and go. But that's certainly something that we never ever want to test.
Okay, but it is your estimate that probably would have not.
No, I think my estimate
Resulted
is
in
that this would have,
loss
yeah,
of-
exactly, that it would have saved the astronaut. That's my estimate. It's a little bit of guessing on my side, obviously, because that is something we don't want to,
Okay, and this latest thing that cannot be fully talked about, the fact that there was at least it basically achieved orbit or very close to.
Falcon 9 did what Falcon 9 was supposed to do. And,
All right, and so presumably if a flaw had been detected in the performance, there would have been contingency plans to rescue the crew.
There
in that, so that-
are always
is there
plans
any-
to keep the crew safe, and we have as I pointed out, we have a late abort capability. We can actually abort when we're close to orbital velocity, and in this case, the abort would be not to land, but to orbit. That's a really, really interesting feature, I think, on Crew Dragon that can always be useful.
And I guess the last question, the probability of loss of mission is a number that is, at least in part,
Right.
an economic trade-off. And so I was wondering, is that something that gets negotiated upward when a project gets in trouble? That as long as you maintain the probability of the loss of crew,
Oh, no,
that
no,
whether it's viewed as an acceptable practice to
no.
make an adjustment of that?
I don't think so. I mean, that would be, safety is our primary
I'm talking about
goal
material.
here.
This is
Absolutely.
loss of mission. This is loss of the payload rather than loss of life. And is it viewed, you know, I would not be shocked or even necessarily unhappy to find that there was some more flexibility in the probability of loss of mission as a project, you know, gets into schedule trouble, for example.
Let me just say, I'm not sure if the loss of mission actually is a problem right now, but in terms of the probability of loss of crew, one of the key drivers is actually the time on station when the capsule sits there more or less empty. There are ways to address this, and we have done, based on the probabilistic risk assessment, we have done design changes, protected hardware, and that's actually what this number is supposed to be for, in my opinion. It's a number that can identify critical areas that you then change the design and add armor, basically, to protect us. That's the main usefulness of this type of analysis.
All right, thank you, and I guess I'm out of time and yield back.
Thank you very much. Let's see, I think the gentleman from California, Mr. Rohrbacher.
Thank you very much, Mr. Chairman. And let me just note that this is a very unique way of approaching achieving a goal that we're looking at today. And usually in the past, we've seen either one contractor or the government itself trying to be the contractor and to accomplish a mission. And what we have are two terrific companies, Boeing and SpaceX, which are providing us a new way of perhaps accomplishing our space goals. And this is the first time I know that we've actually had this type of competition. Let me note that the Orion capsule is reused. Boeing has designed this to be reused. Is that correct?
The Starliner capsule, yes, sir.
Okay. And on the other hand, SpaceX is trying to reuse their launch vehicle. So we have two different approaches, and I think this is what Congress wanted. Some really, we have two different approaches. We're going to find out which one is the correct way. Maybe they're both good, but this is the type of innovation and an innovative approach. I do take it that we have saved money. Is that correct, Mr. Gerstenmaier?
Yes.
So even with two companies and this new approach, we've saved money. However, let me note that the companies are operating under some real burden, and that is not their burden, but I understand that the budget that they've been operating on, that Congress has failed to fully fund this project that they have said they needed so much money. Is that correct, Mr. Gerstenmaier?
Initially, we had some startup problems with funding, but once those problems have been behind us, we've received the funding that we've requested each year for the Commercial Crew Program.
Right. Yeah, I noted that when it first started, we got 64% of the funding, and that was 2011, 2012, 47% of the funding what was requested was actually allocated, and then later on, we have some, at least Congress being more responsible in trying to meet our responsibilities. So this program has saved money. We've got different approaches that are now being proven. And so it looks like the program is going along as we thought it would, even though there have been glitches, but there are glitches in the development of any new technology. Let me note that. Ms. Chaplain, do you have confidence that this was the right approach for NASA to take?
I think in taking this approach, NASA definitely learned some lessons from the past. there were early attempts to work with the commercial sector in a different way and to really have them drive the program and be partners with NASA, but they didn't succeed for things like not very good communication between the contractor and the government, maybe not as much insight as the government needed, not good risk mitigation planning. And in this case, NASA, I believe, took all those measures for commercial crew and the COTS program, and even learned from the COTS program for commercial crew to avoid those past mistakes. So for a program like this that's trying to do business differently, they've instituted.
So do you still have confidence that we should have taken this approach?
It's a good approach for this endeavor. We don't like to endorse one or the other.
Okay.
But for this program of this nature, they're following a good approach and adopting good practices for managing it.
All right, and how about Ms. Chaplain? Ms. Sanders? Do you still have faith in this approach that Congress started years ago? And by the way, when you don't fund a program by what is guesstimated for the need of the program, doesn't that also increase the risks that people take?
Yes, it does, and that can be a problem. I believe that this was an interesting new way to do this. It came with challenges, and if I stick with safety, they learned some new things about managing risk and shared risk management that are probably good for the future. They had to learn some new things because it wasn't the way it was done in the past. I think, by and large, it bodes well for the future.
So do you still have faith in
I have
this
faith.
approach? Well, thank you very much. And Mr. Chairman, let's just note that with this type of, as we move forward now, developing this program, we still face major challenges for things like space debris and how that will, even if they do their job perfectly, they may be in jeopardy with the space debris that challenges our entire approach to space. So thank you very much, Mr. Chairman.
Thank you. Now I'd like to call on the gentleman from Florida, Mr. Christ.
Thank you, Mr. Chairman. And thank you to the panelists here today to share your expertise with all of us. Mr. Gerstenmaier, NASA has invested significant funds and effort in developing and certifying commercial crew systems. And as you know, this program will ultimately serve as a model for future public-private partnerships for space activities. What lessons have been learned from the commercial crew program and can be applied to deep space exploration?
I think there's many, and I can go just through a few. I think, first of all, it's very important that you have the requirements set up front correctly with the partners. And we did that through a requirements development standpoint. We also allowed for alternate standards, which I think is also very important. So we didn't force them to adhere just to our standards, our NASA specifications. We allowed them to provide back to us standards that we initially agreed to up front. And I think that helped to have a very stable understanding of the requirements in place. I think it's also important that we have the ability to add some additional testing if we see it in the activities. Likewise, we have the ability for ourselves to do testing if it's needed. I think we also learned a lot from the commercial cargo program. We could take significantly higher risk with cargo than we can with the life and humans. That allowed us to gain experience, to see what this operating model was like working with two providers. It got us a chance to see where we needed additional insight, and I think that helped us with this program. I think we're about ready to learn a whole bunch of new lessons as we go into this next phase, as we start to close out and do all the verifications, all the validation activities were talked about, actually get the hardware through the final testing. I guarantee you we will learn through that and we will put some lessons in place. It's also very important for us to have the two providers, as was discussed earlier. That gives us another degree of freedom that if we run into schedule problems with one provider or there's a major failure on their systems, we have another provider. So there's a sense of redundancy. I call it portfolio management. By selecting multiple providers, that allows us to ensure we get the capability we need at the end. But I think those are some of the major ones, and I can think some more about those offline.
Great, thank you, sir. Could NASA leverage the vehicles developed under the Commercial Crew Program to support and accelerate its deep space exploration plans?
Again, we can go look at these vehicle systems, design some of the rockets and other pieces and see how they might fit in another activity. But as I described to you, those lessons learned, we can definitely apply some of those acquisition lessons learned, some of those program project management lessons learned for the new programs as we look to lunar activities in the future.
Thank you. Would any other panelists like to comment on this?
Yeah, I think it's incredibly important for the partnership and the acquisition approach to be tailored to the specific mission. For Commercial Crew, I think it was because of our experience in this environment over decades, I think it was the appropriate mechanism. For deep space activity, where there is a lot of research to be done and the requirements by definition can't be stable yet, the approach that they're using is necessarily different. From a specific vehicle use, our vehicle was specifically designed for the low Earth orbit mission. We have not looked at what would be required to use it for a deep space mission. Obviously, it would need some modifications to support those different environments.
Sure.
And,
Doctor?
Regarding SpaceX, obviously we are laser focused on getting the job right now done and get to the space station by the end of the year. That's the highest priority at SpaceX. But if you look at this capsule, you'll see a lot of actually 8 really powerful engines, and those might be useful in other applications too.
Great. My next question I'd like to direct to the two of you, Mr. Mulholland and Dr. Koenigsmann. A recent study done by a NASA cost analyst, Mr. Edgar Zapata, said that fixed price Space Act agreements, as opposed to traditional cost-plus contracting, have reduced cost risks to NASA, the federal government, and therefore the taxpayers at large. Can you discuss your experience with Space Act agreements and why you believe they are a good tool to encourage innovation and at the same time reduce cost?
I believe Space Act agreements have a place, and they were certainly well utilized in the early development phase of Commercial Crew. I think it was incredibly important for NASA to go to a FAR-based contract for the completion of this design and development phase. It is the only way that NASA can leverage contractual requirements on a contractor. So it was incredibly important for both the contractor and for NASA to be able to do that and to hold the contractor accountable and to allow us to have certainty in requirement stability. So I would not advocate using Space Act agreements for future development activities where you're fielding hardware. That said, for early phases, it's very good. Overall, I think the partnership between NASA and the contractors has been excellent, and it has grown more rigorous as the fidelity of the program has matured, and I think that was successful.
Yeah, we had overall a great experience on the Space Act agreement on the COTS, and I think the numbers quoted in this particular article, which I really enjoyed, is I think we saved, it was a factor of 4 to 10 less, I believe, under a traditional cost-plus contract. We believe, in particular, firm fixed is the way to go. It is milestone-oriented, and it gives the right incentives to the contractor or us to keep us, I want to say, keep us hungry and let us perform at our highest performance level that we have. And I think we've been very successful under this particular model.
Great. Thank you very much. Thank you, Mr.
Yes, sir. Thank you. I'd like to call on the gentleman from Florida, Mr. Dunn.
Thank you very much, Mr. Chairman, and thank the panelists for being here today. It's an exciting time to be in space, but not just because of the excitement, but because we see a growing presence of private industry in space. And I like it because they are not for the glory, but because it's good business. In Florida, which Space Florida runs the space complex down there, it actually makes money. It runs in the black. So space is good business, and today I'm particularly interested in how these public-private relationships, commercial relationships are working. So let me start, if I can, with Dr. Koenigsmann. You briefly noted in your written testimony that the NASA SpaceX COTS partnership has the distinction of being this pay-for-performance partnership between government and private business. Can you elaborate more on those innovative fixed-price pay-for-performance contracts and how that leverages the private or the public investment and private investment?
So for one reason, if we, in the unfortunate case that we do need a little bit longer, if that happens, that does not increase the cost, for example, because the payment is tied to a particular milestone, like a certain test or a flight or something you can actually put a certain value towards. Yeah. So I believe it gives you more control from taxpayers' perspective, where the money goes and how the money is split up over a longer period and a rather complex project like Crew Dragon, for example, is.
Actually, so Ms. Chaplain, in general, will you share your feeling about the fixed price pay for performance contracting and how that, from the government's point of view, GAO's point of view, how that's influenced the cost of the programs and the return on those?
So they can be a really good approach to follow, as long as you do have your requirements defined and you're not asking for the contractor to be inventing too much in the program. If they have to go into a situation where there's a lot of unknowns and nobody knows how long it's going to take to get it done or how complex it's going to be, it'd be very difficult for a contractor to sign up for a fixed price arrangement. And that's where the government backs off and goes into a cost-plus environment. And the other issue is, as long as NASA itself has to decide how much control does it want over the situation, how many requirements does it want to specify, how involved in the engineering does it want to be, how much control does it need. So when it feels like it needs more of that control, it's going to also put you back into a cost-plus situation. But in these instances where you can use fixed price, the requirements are known, they can be very good ways to save money.
Thank you. So, Mr. Gerstenmaier, in the cost end of the training side, you now have 3 new different manned capsules. And I presume your astronauts have to train on each of these going forward. How are you going to segment that training? Are you going to is it everybody trains on everything, or a third here, a third there, or how's that work?
Well, at some point, we have 4 astronauts now dedicated to the commercial crew program, and they're in training for the program, but they're also going through design reviews, requirements reviews, seeing hardware, et cetera. We'll eventually assign some of that cadre to the 2 test flights that are upcoming. For the Orion program, we'll have the other astronaut corps doing that. We also have astronauts training for space station. So, several years before flight, 2 to 3 years before flight, we'll start designating crews to the individual vehicles that they're going to fly on, the individual systems that they're going to go do, and begin their specific training for those particular missions. But typically, the crew timeline for training is roughly about 2 years.
Outstanding. So, Mr. Mulholland, in the little time that's left to us, I wonder if you would also comment on the use of these private partnerships and commercial relationships and how well that's working from your point of view.
It's working excellently. We have a great relationship with Space Florida. We were able to relocate our program down to Florida and use the extensive resources that we had right there at the Space Coast. So it's a great model going forward.
Thank you very much, Mr. Chairman. I yield back.
Yes, sir. Thank you. Now I'd like to call on the gentleman from Texas, Mr. Vesey.
Thank you, Mr. Chairman. And I wanted to ask a question specifically to Dr. Sanders. I wanted to know if he could elaborate on why the ASAP views safety culture as critical and why the ASAP remains concerned about the provider's safety cultures and the evidence that you would use to confirm its presence.
Safety culture, you can put all the requirements you want to on a program relative to safety. You can say you've got to do this, 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 and this. But if it's not something that the entity embraces itself and really believes is important themselves, then it doesn't really work well. And so it was important to us to see that, the commercial providers had this culture embedded in them. There was early on some evidence that there might be a lack, a little bit of a lack in safety culture. We saw a few things that raised a flag for us. And so we wanted to see more insurance that was there. It doesn't have to be, we were trying to make the point at the time that it isn't that there's any one way that you necessarily make safety happen, become a priority. It has to be something that people believe in. And so that was important to us.
Mr. Mulholland and Dr. Koenigsmann, can you talk about culture surrounding safety at your respective companies, and how do you ensure that schedule concerns do not drive decisions that should compromise safety?
Yeah, absolutely. Actually, thank you for the opportunity. And I do want to point out, I totally agree with Dr. Sanders on this. If you don't have the corporate culture of safety, then all the requirements, then they're good, but there's still, you do need the safety culture as a basis to actually create a safe and reliable capsule and launcher. And that is actually my job at SpaceX. I'm the head of the flight reliability and build reliability departments. And my job is to make sure that we have a safety culture that translates into quality hardware and that translates into a safe launch. And I use my method. Obviously, is might be different from others, but I use a lot of talking directly to people. And then, in addition to the formal reviews, I go a lot of sideways into places and talk to the technicians. I look at the capsules. For example, I looked at the Crew Dragon capsules. There's 3 capsules right now that I saw in the factory, and I talk to engineers and technicians working on it, make sure that they have the right safety culture and understand the significance of flying astronauts here. Absolutely.
Hey, I certainly appreciate the question, Congressman. It's an area I've got a lot of passion around. Our company has essentially grown up with NASA through the human spaceflight program. We've been a trusted partner with NASA on every human spaceflight program that this country has performed, and we're very happy to be able to maintain that. So culture for us. Our culture and our safety focus, I think, is very strong. It's something that we have across our entire company. Our business is to field and deliver transportation platforms. We do it for the commercial aviation sector, we do it for our servicemen and women, and we do it for human spaceflight. And the way you develop that culture is over time, and it's with the decisions that you make. It's how you treat your employees, and it's how you deal with technical issues, and having a robust focus on engineering discipline and the safety decisions that you make. So it is something that takes a long time to develop, and it's something that an organization has to be passionate about to maintain. And it's something that I think over decades, this company in particular has demonstrated.
Thank you. Thank you, Mr. Chairman. I yield back.
Yes, sir. Thank you. Now I'd like to call on the gentleman from Indiana, Mr. Banks.
Thank you, Mr. Chairman. So as I understand it, the mission management team historically was in charge of reviewing possible mission issues during and after flight. Members from different areas of NASA sat on the board, and the MMT even had a vote in the go, no-go poll before a launch. So the MMT simply functioned as a safety watchdog. My first question is for Mr. Mulholland and Dr. Koenigsmann. What safety programs are currently in place to match the role previously played by MMT at Boeing and SpaceX? Mr. Mulholland?
Yeah, excellent question. So growing up on the Space Shuttle program and seeing the foundation of the mission management team approach, our mission management plan is going to mirror that we implemented on the Space Shuttle program. So we will have a mission management team. NASA will be part of that mission management team. We will have similar reviews heading up to and into launch, both from the flight readiness review and L-2 review before we commit to tanking the vehicle. And they will be fully up, the mission management team will be up and running from that FRR on in, consistent with how we operated the shuttle program.
Okay. Yeah, slightly different name on our side. We call it flight reliability, but nevertheless, I actually I learned from the shuttle, obviously too, and why change something that worked. And so we created a similar approach where we review and test and verify as we go along. There, I do want to also, maybe mention that Falcon 9 is usually we can static fire it on the launch pad, so that's a possibility to do a very last test in the last week before launch, make sure that this vehicle is ready to go. It's similar to running up the engines and make sure that that the vehicle is ready to go. So in addition to taking the traditional approaches, we've added elements there that we think contribute to safety and reliability.
Okay, thank you. As a follow-up to that, to both of you, who would have the final say on whether to launch in a SpaceX or Boeing vehicle? And would NASA be able to call off the launch, or would Boeing or SpaceX have complete authority to decide to launch?
NASA has the final no-go for flying their crews.
Yeah, I believe that's the case on our side too.
NASA has the authority to override the contractor decision and do what's right for the crew.
Okay, thank you. I understand that SpaceX is planning on water landings while Boeing will be landing vehicles in the desert. What procedures does each company plan to put in place to ensure the safe retrieval of astronauts once they've landed? Mr. Mulholland?
It is our responsibility, and there's a whole set of NASA requirements on what has to be fielded out at the retrieval site, which includes medical personnel, the ability to transport the astronauts to a local hospital within an hour. There is a whole set of requirements, and we've got the infrastructure in place or in work to support that.
Okay. Yeah, and we obviously got the same requirements from that perspective, and we have the ability, we have a ship, we have the ability to land a helicopter, and we actually, this particular, the way we get the capsule out of the water, that is something that we do currently on every Crew Dragon, last time on Saturday morning or Sunday morning, I think, on the last flight. So it's a routine activity for us, obviously upgraded and with additional personnel for to make sure the astronauts are safe.
Okay. Does each company have a plan for emergency landings in areas other than the primary landing site?
Absolutely. So our plan nominally is to land on land. Because of the trajectory that we fly, if we end up in an abort situation, we will land in the water. We'll be certified for that also. In the situation of an abort, the NASA and the government forces will do the retrieval.
Okay. Doctor?
Yeah, we do rely on also on government support in case of a wrong landing in the wrong place or the wrong spot, obviously.
Okay, I have a few seconds left. Mr. Gerstenmaier, as NASA continues to buy seats on Russian spacecraft to travel to the International Space Station, will this practice stop once the commercial crew program is ready, or will NASA continue to purchase seats on Russian aircraft?
We will not purchase seats on Russian Soyuz after this program becomes operational. We still will continue to fly our crew on the Russian Soyuz vehicle, and we will fly a Russian cosmonaut on our U.S. crew vehicles. And the purpose for that is to ensure that we always have space station manned with one Russian cosmonaut and one U.S. astronaut so they can operate the appropriate systems. Station requires operations of the Russian segment and the U.S. segment, so we need to have a mixed crew on board. if a contingency occurs, the crew gets in the vehicle they arrived on and they need to return to the Earth. So to keep that mix on orbit, where we have a Russian cosmonaut and a U.S. crew member, we need to then share crews across our vehicles. So our plan is no longer to purchase seats, but we will still have the ability, we will still fly a U.S. crew member on a Soyuz, and the Russians will likewise fly one of their crew members on our U.S. crew vehicles.
Thank you. My time has expired.
Yes, sir, thank you. I'd like to recognize the gentleman from Virginia, Mr. Byer.
Thank you, Mr. Chairman, very much, and thank you all for being with us. Dr. Koenigsmann, can you give us an update on SpaceX's timetable for manned spaceflight to Mars?
I'm not. I don't think I'm qualified for that. I mean, obviously, that is a long-term goal that our founder and CEO, Mr. Musk, has, and there is a team working on this. But it's I want to say it's a relatively modest team, and the main focus on the company is clearly on this particular program and getting to the space station. That is our first step into the manned space travel.
My colleague, Mr. Perlmutter from Colorado, has a seat on NASA's 2033 flight to Mars. But we're all... Yeah. If we can get rid of him earlier, that would be very helpful. And you know, one of our previous friends on the Republican side talked about how wonderful it was that we were now in our space industry could make money off of it rather than just doing it for the glory. Tell me, Mr. Koenigsmann, from a SpaceX perspective, cars aside, is there a viable business model? We know the satellite folks have done really well, the orbital ATKs, but can you make money doing these crewed missions also?
So I want to say we actually brought the commercial space back to the U.S. We had 18 launches in the last year, and I want to say 60-something% of the commercial market is now done by SpaceX. I hope I got my numbers right here, and that obviously is a commercial aspect that gives us an additional leg to stand on. Notwithstanding that the crew program obviously gets some funds into SpaceX too, but I do want to point out that we are diversified and looking at commercial launches as much as government launches too. There's additional benefit, of course, for Crew Dragon, and the benefit is that we're using the same rocket over and over. There's no change here. And that makes us a very well-practiced team with a lot of experience and a lot of data. I personally, I've been building rockets for 15 years at SpaceX, and I must say I learned a lot, in particular in the last year, just by pure repetitive launches.
That's a good lead-in, because we talked a lot about the Soyuz rockets.
Right.
Yes. And I've toured your facility in California and seen the engines that you built. Can they replace Soyuz?
Yes, I think so. I mean, the engines are we built almost everything basically in house, and the idea is to keep control of cost and schedule if you build it in house, and it's end to end. It's the launch vehicle all the way up to Crew Dragon. There's no gap here.
Mr. Mulholland, is there an opportunity to work together with SpaceX on the part of Boeing, ULI, et cetera, in terms of the engines?
From a launch vehicle standpoint, because we go out and we contract for that launch vehicle service. So we competitively competed for our launch vehicle for the initial phases of Commercial Crew. For us, Atlas V was the only launch vehicle that had the mission assurance, reliability, and safety record necessary to fly crew. Obviously, if we look at long-term life cycle affordability, we will continue to look at different launch vehicles in this class. And when one exhibits the safety record and reliability performance that we think is necessary for crew, we'll certainly consider that.
Great, thank you. Mr. Gerstenmaier, we in Congress were struggling with how to react to the Russian interference in the 2016 election. And we're increasingly realizing that they've interfered in elections all over the world, all over Europe. Have you seen any Russian disinformation interference in the space culture?
We've seen no evidence of problems in the space culture. I think as we described in this hearing, we talked about a safety culture that was required, that needs to be in place to ensure safe flight. We have a very strong relationship with our Russian partners. We share the same strong desire of human life and protecting human life. We work together fairly seamlessly together to work technical problems and issues. We share data back and forth very openly. We recognize the challenges of putting humans in space, both the Russians and the U.S., and so far the space industry has not been subject to other activities that could be seen as bad. The focus of protecting human life drives us to a higher calling to be more open and transparent than would be maybe normally required.
Great, thank you very much. Mr. Chair, you.
Yes, sir, thank you. Now I'd like to recognize the gentleman from Florida, Mr. Posey.
Thank you very much, Mr. Chairman, and thank you, panel, for your appearance today. Mr. Gerstenmaier, on what date does our contract with the Russians to transport our astronauts back and forth to the International Space Station, what is the date of the end of our contract with them?
The last launches are in the spring of 2019 with their crew returns in the fall of 2019. So by probably October, November of 2019, we need to have some established way for commercial, the U.S. providers to be delivering crews.
Okay. How many missions do we have between now and then?
It'd be Soyuz missions we have between now and then. We have roughly, we do 2 Soyuz missions in the spring and 2 Soyuz missions in the fall. So we fly essentially 3 crew members in the spring and 3 crew members in the fall.
Okay. How many do we have scheduled after that?
After the 2019 date with Soyuz, yes, we have none.
No, nothing scheduled for the ISS?
We only have what I described before, where we will fly one of our astronauts on the Soyuz vehicle for safety considerations, and we will fly 1 Russian on our U.S. crew providers. But beyond that September 2019 date, we have no further ability to use the Soyuz directly for our purposes.
But what is the need for missions to the space station? How many more missions do you think we'll need to have to the space station?
We'll need, again, from then through the end, probably 12 missions or so. Again, 2 per year, same kind of.
2 per year for the next.
Till the, and station goes through no earlier, end of station is no earlier than 2024. So that would be 2019 through 2024. So okay. 5 years at 2 per year.
Okay. Mr. Mulholland, when do you think you're going to be flight ready?
Yeah, we have high confidence in our plan. We'll fly our uncrewed flight in August of this year and our crewed flight in November of this year.
So you think you'll be online by spring of 2019?
Yes, sir.
Okay. Mr. Koenigsmann, how about you?
It's about the same. We have an uncrewed flight in August of this year, and then we have a crewed flight planned for December this year.
Okay. Just out of curiosity, Mr. Gerstenmaier, what are we paying the Russians per seat now?
It's on the order of $70 to $80 million per seat.
Okay. Are they going to pay us when we carry their people up there?
No, and we're not going to pay them for them carrying our astronaut to station.
But they won't be carrying our astronauts after 2019, will they?
Yes, they will, for the safety reasons I described earlier. We will continue to have 1 U.S. crew member on every Soyuz flight that flies to station, and we will continue to have 1 Russian on one of our U.S. flights, and that's to keep station viable with a Russian cosmonaut and a U.S. astronaut on board station. Okay. And that will be done under a no exchange of funds basis.
All right, so we'll carry ours and at least one of theirs, and they'll carry theirs and at least one of ours.
That's correct.
Okay. Thank you, Mr. Chairman.
Yes, sir, thank you. Now I'd like to recognize the gentleman from Colorado, Mr. Perlmutter.
All right, thanks, Mr. Chairman. And Mr. Gerstenmaier, let me start with you. In November, we talked a little bit about the Dream Chaser, and they were actually having a test flight and drop back in November when we last visited. And can you remind me what it is that NASA has planned for the Dream Chaser? It's primarily cargo. Anything else?
It is cargo, and it's both pressurized and unpressurized cargo to the station.
Is it possible, I guess anything's possible, but is it possible it would be a backup to SpaceX and Boeing?
Not at this time, because our requirements for safety are dramatically different between the cargo program and the crew program. For the crew program, we have much more stringent requirements and ability. We have the requirement for an abort capability in the vehicles. And currently, as Dream Chasers envisioned for the cargo missions, it doesn't meet fully all those requirements. And also, it doesn't have an abort capability as it's currently envisioned for cargo.
But if either of the contractors were to slip up, those kinds of things could be changed, I imagine.
Through appropriate procurement and competitive procurement activities, yes.
Okay. Can the panel talk to me about load and go and what that means to all of you and what you expect? And I'd start with you, Dr. Koenigsmann, if you would. Just some concerns that have been expressed that when you're fueling the rockets and the spaceship or whatever, that there's a little additional danger at that point. So, I mean, I'll just open it wide open and start with you, sir.
Certainly. I mean, we use what we call densified fuel. It's subcooled, actually, way below the boiling point, and it's particularly adequate to load it actually fast and quick. And what we try to do here is we try to minimize the time we expose personnel, not just astronauts, but also crew, to the hazard of fueling. So in this particular case, our procedure is actually that we put the astronauts, we strap them in, we make sure they're comfortable, and then the ground crew retreats, and we arm the pad abort system that we already tested. And then we start fueling the main propellants basically within what amounts to like half an hour or something like that. So it's a relatively quick procedure, and we believe that this exposure time is the shortest possible, and therefore the safest approach. I do want to point out that when you load traditional propellants, you basically load them, LOX at least, at their boiling point. So you're constantly refilling while the gas basically goes overboard. It's not, it's described, some people say it is quiescence, but it's actually a constantly boiling process that needs to be refilled from the other side. So we don't consider that as a really quiescent stage either.
All right. So from SpaceX's point of view, the purpose is safety.
Correct.
I mean, so you think it's safer to do that. Does anybody else have a comment on load and go? Mr. Mulholland?
Well, load and go is an approach that the Atlas V doesn't take, and I think that the Aerospace Advisory Panel, NASA, appropriately has significant concerns over that approach. It's something, and obviously I don't know the specifics of the SpaceX system, but using densified propellant was something that we considered years ago in the Space Shuttle program when we were looking at for additional performance capability, but we never could get comfortable with the safety risks that you would take with that approach. When you're loading the densified propellant, it is not an inherently stable situation. With the approach that the shuttle took, the approach that the Atlas V takes, you do load the propellant, and then you enter into a period called stable replenish, because that system then is thermodynamically stable. So you are flowing a small amount of propellant in just to maintain that thermodynamic stability. So I have great trust in ASAP and NASA and working with SpaceX to determine that whether that is technically and from a safety standpoint feasible.
Quickly, Mr. Gerstenmaier, Dr. Sanders, just quick.
What we'd like to do is not have a kind of a word discussion about where this is, but we're going to actually take the vehicle design. We're going to go look at the specific hazards associated with the various phases during loading. We'll look at when the crew goes on board. We'll look at what those hazards are, what the likelihood of those hazards are, and we'll make an informed decision about when, for this particular rocket's design, is the safest time to put the crew on orbit. So rather than picking words such as load and go or stable replenish, we're not going to do that. We're going to go below that. We're going to understand the specific risks. We're going to understand the specific timeframes that the crews are exposed to hazards, and then we'll make an informed decision about the appropriate time to go ahead and put the crew on orbit. It's also important that if we stay with the same approach that SpaceX is using for their cargo flights, we gain a lot of experience of understanding how this rocket gets loaded, how the ground systems operate, the loading systems on the ground, how reliable they are, how safe they are, et cetera. That's an important consideration as well, too. It's not only the rocket that can damage and hurt the crew, also the ground system can have problems and failures that can also hurt the crew. We need to look at it in an integrated system. We have the plans in place to methodically review this, look at the hazards, and find the appropriate time to put the crew on board the vehicles, and we'll do that at the appropriate time.
Thank you, Mr. Perlmutter. I appreciate your time's expired. And I just want to thank the witnesses for your valuable testimony and the members for all of your questions. The record will remain open for 2 weeks for additional comments and written questions from members. And I'm not going to be able to shake your hands because I've got to run to another event, but I want to say thank you so very much. This has been very, very informative. Two great companies, and we appreciate all this information. Thank you. This is adjourned.
See you, Doc.
Hey, you bet.